Hello friends, welcome to Unacademy, which is the largest online education platform for GATE, CSE and IT. Myself Mallesham, I'm working as an educator on Unacademy, where on this channel I am going to take the classes for theory of computation, compiler design, C programming and also discrete mathematics soon. Yes. Yeah, good morning Vijayant. Good morning Himanshu. Good morning Gaurav. Nandi, good morning. Yeah, good morning guys. Rishu, good morning. Nikhil, good morning. Yeah. In this session, I'll be taking one important session, which is the Turing machine. And Turing machine, we don't need to construct in the exam, but theoretically you should be very good at answering the questions of the Turing machine. So this is what happening in the exam, and why they don't ask the Turing machine, because to understand the configuration of the Turing machine, which may take minutes, so asking the question about the construction of the Turing machine may not be possible in the exam. So that is how, once in a while it might happen, but in 30 years I have seen that two questions were there about the Turing machine configuration. Yeah. Good morning, Mahendra. So I don't want you to focus more on construction, and of course we design the construction of the Turing machine, but rather than designing the Turing machine designing Turing machine, we will look into the all theoretical details, how Turing machine going to help us in identifying the languages that we are going to focus a lot. Okay. After today, next session I'm going to explain about undecidability, and 16th is the very important session for you. We are going to combine all languages in one class. So entire 2 hours is going to talk about finite language, infinite language, regular language, DCFL, CFL, CSL, including recursive and RE languages. All the languages will come into one class on day after tomorrow. Yes. Nagendra, good morning. And I hope all these 4 subjects are completed. Right. Now the subjects are going on: algorithm, morning 6:30 a.m. by Ankush sir, and I'm taking TOC, and OS is going to begin today. That is by Khalil sir, and data structure started yesterday. Yeah, soon, or but soon, once these 4 subjects are completed, we are also going to start remaining subjects. Fine. In case you want to know about my expertise subjects like TOC, CD, Art, CEDS, Algo, Discrete Maths, and even OS also have taken some classes earlier, but these are my expertise subjects, and this is my referral code DEVALIVE to get 10% discount on Unacademy, and also which will help you to access the free classes on Unacademy. So if you believe me and you wanted to prepare GATE with the support of my guidance, then use my referral code. I will help you to crack the GATE exam, and not me, just every educator of Unacademy is going to help you. But in case if you are using my referral code, I take more responsibility to help you. Yeah. And if you want to know about my free classes on Unacademy, like I have taken the quizzes, all-in-one sessions and special topics on TOCC, CED, Discrete Maths and Algo, daily practice problems and PYQ series on many subjects. Right. This is my URL, unacademy.com/DevaGateCSE is my profile URL. Directly use this, or if you are already on Unacademy, just search my name Mallesham Devasane on Unacademy. You will get my profile. Directly you can access all the classes. If you are using mobile, you wanted to use the Unacademy Learning app, go to Play Store and search for Unacademy Learning app and install it. So you can use it once you log in into this app. Yeah, Unacademy has 2 popular subscriptions, Plus and Iconic. Right. So every online platform will have kind of courses, but Unacademy has a different kind of subscriptions where it gives unlimited access once you take an entry into Unacademy. You might be using my referral code. It doesn't mean for my classes. It's going to give you an access to every class on Unacademy, right? That's the beauty of the Unacademy entry. It's like just like Netflix. All courses are structured. You are able to access every educator course, right? You can use my code, but you can access my classes as well as every educator class on Unacademy, and you will have weekly tests, you will have doubt solving sessions, and you will have batches for both English and Hindi from top educators. That's why we recommend to go for subscription. And Iconic, all the benefits of Plus. Additionally, there will be dedicated coach and who are already cracked the GATE exam and will be helping you to prepare for the GATE exam. And you will have a separate study material, other sessions and analysis of your test, attempt and study planner and many things. In case if you want to know the plans, like Plus there are many plans, among them 2-year plan I am talking about. You have 39,600 if you are using my referral code DEVALIVE. And similarly, Iconic has many plans. Here 2 years you have 66,600, and we always recommend to go for 2 years. The reason is more benefits. You need to learn courses from every educator and you need to learn from entire batch. So this makes time you can't do in 1 month or 3 months. So we will recommend to go for 2 years. But 1 month when you have you want to only attempt test series, or you wanted to attend only some revision courses, then 1 month, 3 months, 6 months are going to help. Yeah. Good morning, Pratiksha. Simon, good morning. Aparna, good morning. Lojit, good morning. How are you all? Good morning. How is your preparation going on? Great. So we have completed regular languages and context-free languages. Now we are moving to recursive and recursive enumerable languages, where the Turing machine support is needed. Okay, Simon. Yeah, even in South also we have festival. Raj, I am not taking complexity theory because which is not there in the GATE. And if you want to need, you can come to Unacademy special classes. You can discuss with me. I will help you, Raj. NPP classes are not part of the GATE syllabus now. Complexity theory is removed from 2016 year. Okay. So today Turing machine, construction of the Turing machine, and if time exists, we will go for closure properties of recursive and RE languages. Okay, let's start without wasting the time. In Turing machine, what we are going to learn very simply, what is the definition of a Turing machine and how Turing machine looks like, configuration, and deterministic Turing machine versus non-deterministic Turing machine, and linear bound automata, HTM, TM. What is the difference between these three, and what is the difference between recursive and RE language? Yeah. So what is a Turing machine, guys? What do you know about Turing machine? Quick. What do you know about Turing machine? If you ask me Turing machine, assume this, you have built a Turing machine. Assume that you build some Turing machine which accepts some L. I will talk about what is this L. Basically, Turing machine accepts recursively enumerable language. Everybody knows that. So I am just assuming it is L. And if this Turing machine accepts L, then what is the behavior of the Turing machine? Yeah, it's a computational model and program. Pratik, program just. And give any input here. This input so far you might given A, B, something like that. Now you can give an input as a grammar, a machine or expression or language. Anything is possible for this TM. This is just considered as input string. This string need not be sequence of symbols now, but it is a too complicated machine, but slowly we will understand that. Yes. In case W belongs to L, show the logic always. Logic definitely exists because Turing machines are built to understand the valid members or valid inputs. Yeah. If it is W not in L, you no need to show the logic. We no need to build a logic. If you want, you can. Or we no need to prove that we always halt. Here two things will happen. Logic exists means it always halts at final state, either deterministically, non-deterministically, it doesn't matter. Always halts at final state. Either you will have one path or at least one path. That depends on the type of machine. Like if it is a DTM, we need to prove like exactly one path that halts at final. If it is NTM, at least one path. For valid string I am talking about. Invalid string, you just leave it. But if it is a DTM, show exactly one path. If it is NTM, you can leave it. So what happens, whether it is DTM or NTM, invalid string, I am talking about invalid input. What happens for invalid input? Either halts at non-final if you have a path. If it is DTM, definitely you will have a path. Either halts at non-final or that Turing machine may never halt. This behavior is very dangerous for the Turing machine. Yeah. We really do not know. We really do not know until we design or somebody designs it. So somebody will talk about invalid string, will it halt or will it not halt? Yeah, kind of a loop. But here loop need not be Pratik and Lavjit. You know, the head can move forever one direction, either left or right, or sometimes right, sometimes left. There are three ways it might happen, never halt. Okay, I'll be talking about that. In program, it's just like kind of a loop. Yeah. Now, is it important to build a logic for invalid string? Not important at all. So if anybody asks, what is the definition of Turing machine? We will always show logic exists for valid strings of Turing machine. No need to show, no need to prove we have a logic for invalid string. Remember the definition. Note, we always build, when we construct, we always show logic exists for valid inputs. Invalid may or may not exist. This is a very important point why Turing machines are very powerful today, because you don't need to talk about valid invalid both. But in case if you talk about, the Turing machine will become a special Turing machine in the world, that will become halting Turing machine or linear bound automata. So many types of Turing machines in the world when you restrict them. Yes, we'll talk about that soon. Yeah. Let's talk about the configuration. Configuration. What is the configuration of a Turing machine? You might know what is the finite automata. Even now, I no need to restrict one side. You can, sorry guys, you can use the two-way infinite tape if you want it. Now look at how powerful it is. Now this head can read or write onto the tape, and this head moves bidirectional now, left right bidirectional. And if you have any input here, the remaining symbols we always assume which is not your input. We assume because head can move any direction. By default tape is occupied by blank symbols. This is infinite tape, remember that. Never restrict this tape because Turing motion can execute forever using this tape. That's this head can move forever one direction and forever, that is either left or right, or it can move sometimes right, sometimes left, sometimes right, sometimes left. That can go to infinite loop, guys. And that's why a behavior of the Turing motion sometimes can enter into infinite loop, we say that. Yeah, this is the finite control. Like a finite automata, you have a Turing motion configuration too. There's such states and so many things. When you look at the Turing motion, we have Q, sigma, delta, Q naught, F. Apart from this, in stack we have a Z naught, here we have a blank, and here we have a tau. I'm just differentiating. Yeah. Good morning, Pratik. Everything is possible, Rohit. If you have some meaning, everything is possible on Turing motion. Meaning should be there first. Yeah. Here two new parameters. This is special symbol on the tape. We call blank symbol. Entire tape occupied by blank other than your input. What is tau? Is a tape alphabet now. Why tape alphabet is required? This was not required for a finite automata PDA because sigma and tau they are same. We never cross your input there. Your input is there. Finite automata and PDA will only access your input symbols. That's how we designed. Here, after some time, this A might be replaced with X, this B might be replaced with Y. Then what's happening? What's happening? Here, sigma is just A comma B. But when tau comes, when you come to the tau, anybody guess what is the tau, guys? What is the tape alphabet now? Not only blank, not only X, not only Y, even input is also tau symbol, tape symbol. Yes. Everybody, you need to realize first, why do you need a tape? Because here, other than the input, we might write with the new symbols on the tape. So you require tape alphabet to talk about input symbols, to talk about the new symbols that you write, and to talk about the blank symbols on the tape. Yes, exactly. Good logic. Clear this point? And now you should know how Turing motions are designed with the help of transition function. Because this transition function is really needed to understand about the Turing motion design. XY is not input, Pratik. It's not input. AB was the input. XY is your logic within your configuration. You are writing with new symbols to understand your problem. Yeah. What is DTM and TM? If you talk about DTM, delta is Q cross, DFA, remember sigma we used to write, now tau we use. Why, guys? Because now we always read the tape symbol rather than just input. First time you might be reading input, but later on after some time you might get other than the input. So always safe side, use the tau. And what is the relation between tau and sigma? And sigma is strictly subset tau, but you may use subset or equal, that's fine. And blank is belongs to tau. Everybody? So all the symbols of input alphabet is covered on the tape, no doubt. And here Q cross tau cross direction, left or right. Some Turing machines have more capabilities. They can also stay there instead of moving left, right. It's their choice. But standard Turing machine, this is going to talk about, like, if you want a present state, you need to represent here present state, and you want to read it, read tape symbol, no need to input. You need a tau, and you want to go next state, you need here codomain element, and tau, what symbol you are writing, write with some tape symbol, and direction either left or right. Yes, good Pratik. Everybody, so when you are talking about these 5 parameters, and you should be very careful, in domain we have 2 parameters, here codomain we have the same 2 parameters again, but including direction. So what is the present state, what will be next state, what you are reading, what you are writing, and which direction you move, right? Tau is set of tape symbols, Gaurav, that you have not seen so far. In finite automata, PDA, tau and sigma were same. Tau is tape alphabet. Tau is all symbols that you use on the tape. All symbols used on tape, that comes under tau. Why do you need a different than the sigma? Because we don't have a stack here. We have only tape where you read and write. If you are reading, you might be doing first input symbols, but you can write on your own symbols like X, Y. Yeah, Gaurav. You just wait for some time to see an example. You are really hurried, I will give an example. Okay, NTM. Here everything is tape. We don't talk about input. Input is just first the beginning, because after some time to understand, I may require to write something else. Q cross tau. Here now 2 power. There could be many transitions for the same combination of state and input, state and tape symbol. Now input we don't speak. Yeah. So this is NTM definition. It's a more complicated than PDA and finite automata to understand the configuration. Yeah. So to understand this, let me talk about, suppose you want to read it. I'm talking about reading. I want to just read symbol A, let's say. Read A. I don't want to write with anyone. So what do? You have A and you need to write with A only. Then only I know that just read A happened. We didn't write with anything. That means A write with A only. I don't want to write. I just want to read. Maybe let's say I'm at state Q. I want to move left direction. Let's say I want to move to Q dash. Then how to represent, guys? Delta of from Q by reading A. I am moving to Q dash. A I am writing with A but moving left. You have to specify everything here. That means just reading A but you moved left direction. You want to move right? Just take R. Just write R. Everybody, look at how to represent. Suppose I want to write. I want to read A but I want to write with X. So then what changes happens? This A you are writing with X on the tape. Then this A, that codomain element, you need to replace A with X. That's all. This is you are reading and here you are writing. This is a tape symbol. This is also tape. That's why tau is required rather than a sigma. Sigma, you can't change it. Sometimes sigma, sometimes tau. Everybody? Yeah, these parameters are very important. You are reading tape symbol, you are writing tape symbol, but in the beginning it might be input or yes. Okay, now how this gonna be different from finite automata and PDA? Before starting designing, guys, how this is gonna different from finite automata and PDA? Let me help you. In finite automata, you can't write it. Only tape, only sigma was there. Tape is your sigma, sigma is your tape. That's all. That's why tau doesn't come there. Even PD also, sigma and tau both are same. But gamma was there, that is to represent stack. That's a different data structure. Fine. So in finite automata, we have only one way we can remember, that is by changing the state. If you are changing the state, let's say on A, that means you remembered A. If we are changing the state on the this kind of machine, we remembered it, means of course somehow. If we are changing the state in finite on A, input A, then we remember that symbol. This is how in the finite we do always. But in PDA, we have many options now. In PDA, either you can change the state, that is also possible here. But with the changing the states, only few things, because you can't design infinite states in a machine. So what you have, you can push symbol onto the stack. That means we remembered it. Somebody is gonna pop, so that is compared. Push symbol onto the stack. Or you can do both. Yes, to remember this symbol, we can change the state, or we can push something, that symbol onto the stack. That means this is how we remember on PD. How to remember? Turing machine. Here also we have a power. You can change the state. You can also do that. By changing the state, you can remember, or you can also write with like X, Y, Z. A you are reading, you can write with some other symbol rather than the same symbol. Write with some type symbol, not with input symbol other than the input. Write with some type symbol rather than the input symbol to remember. Yeah, pop also Pratik. Okay, that's fine. If without push, pop never happens, right? So push to remember, pop is also remembered but compared. Yes. Clear? Is it clear? If you want to remember something, there are many ways to do on different machines. Okay. Now if you want to compare these three machines, which is more powerful? Turing machine is more powerful. So we always represent, this is the expressive power of the machines. Finite automata is less powerful because it can only understand regular languages. PDA, it can understand all languages accepted by FA, all regulars and also some of the non-regulars, so all of them called as context-free languages. Turing machine is going to understand all problems of FA, all problems of PDA, and it has its own problems to understand. Yes, RE languages we call. Okay, now we have three kinds of machines, guys. Most of the people, they worried about these three machines. The reason is all the three are Turing machines only. The configuration, when you look at, all the three are Turing machines only. All the three are Turing machines. But you know, right, the Turing machine, how do you design? Every valid string that machine holds, every valid string or input, whatever, every valid string machine holds, it holds at final. That is the definition. Invalid string never. And HTM, here it is TM, no doubt, it is TM, but always halts. Already we know valid string always we halt in Turing machine, but HTM not only just for valid, both valid and invalid we halt. both valid and invalid inputs or invalid strings, we halt, the machine halts. But valid string we halt at final, invalid string we halt at non-final. And when you talk about LBA, it is, you can say, HTM. What is HTM? Halting Turing machine. Basically, LBA we design non-deterministically, remember, because deterministic is difficult. And today, till today, nobody knows the relation between deterministic and non-deterministic in LBA. So it is HTM, means it always halts, but it uses bounded tape, that is also linearly. And that word really difficult to explain now without examples. It uses a bounded tape, it never uses infinite tape. But HTM and TM, they can use infinite tape. Good morning, Sweta. Are you clear? And I can say that all are Turing machines. But when you restrict Turing machine, you get other types. Even I restrict the Turing machine, I can get a finite automata too, guys. If I restrict the tape is read only, head is moving one direction, Turing machine will become finite automata. Everybody? Even finite automata also I can say it is a Turing machine where the head is read only, tape is read only, head moves one direction. I can say that if I want to speak about the finite automata in terms of Turing machine. But anyhow, finite automata has its own configuration, so we don't. But LBA, HTM, TM purely depends on Turing machine configuration, guys. Everybody, they're not different from Turing machine, but they have the different behavior than the Turing machine. Turing machine always halts for valid string. We don't know whether halts or not for invalid. But HTM always halts. It is a Turing machine. It always halts whether it is valid or invalid. LBA, it is going to halt always, but it uses bonded tape rather than infinite tape. Clear this point? Yeah. And this LBA accepts which language? Context sensitive language, whatever the language that are accepted by the linear bound automata, whatever the language accepted by HTM we call a recursive language, and whatever the language accepted by TM are recursively enumerable. So what is the relation here? The CSL and recursive both are comes under recursively enumerable. Every CSL we say it is recursive enumerable, and every recursive is also RE, but RE no need to be CSL, no need to be recursive. Okay, now this is about main theoretical points of Turing machine. Now recursive and RE, how you gonna define these two languages in this chapter? Recursive are also accepted by Turing machine, RE are also accepted by Turing machine, but recursive are accepted by special kind of Turing machine where it always halts. Look at that. Yeah. Suppose you build a Turing machine. In case when you give an input, it's halting every W. I'm talking about every W belongs to L and every W not in L. Suppose always halts. What kind of machine it is? This Turing machine only called as halting Turing machine. So here this TM accepts. We call L, but that L is now recursive. Everybody? So this Turing machine is called as halting Turing machine. And in case if you are designing a Turing machine, you are only designed belongs to L and you left it, but you don't want to talk about invalid. You don't know what do? Leave it. Leave this invalid string combination. You have not designed it. Or you might be designed, but you never, sometimes you may not halt. Yeah. Here no need to talk about invalid string. It may halt or never halt. It is your choice. Even you design every string, you can go to infinite loop, doesn't matter. Even regular language also, I can design a TM, invalid string, I can go to infinite loop even for regular language. Right. So, if the Turing machine always halts, that we call HTM. And you don't know what you are talking about, just simply talk about Turing machine. That it halts or not doesn't matter to you, then say Turing machine. So, language accepted by halting Turing machine is recursive. Yes. Language accepted by Turing machine that always halts. No need to say halting Turing machine, say Turing machine, but that always halts is recursive. If you want to say about recursively enumerable, don't say always halts, we don't know. Language accepted by Turing machine, that's all you say. Language accepted by TM is RE, that's all. Clear? This RE, is it recursive or not, depends on what Turing machine you have designed. If you design like the first kind, then that will become recursive. And we have something else. In case if you design a Turing machine, if that can enumerate in a lexicographical order, you can enumerate the set of string one by one. You can enumerate language, but entire language you can't design one at a time. You you enumerate one by one. If this enumeration is effective lexicographical, we can say dictionary order. If any Turing machine is enumerating a language in lexicographical order, then that language is called as recursive language, because recursive languages are always possible to enumerate in lexicographical order, right? Language enumerated lexicographically is recursive. So it is now recursive language. This is also recursive. And in case you want to just enumerate, don't want to talk about lexicographical, just enumerates. Don't talk about any order. Then simply say RE, recursively enumerable. It may be recursive, it may not, depends on which order you are designing. Yeah. So this is another behavior of the Turing machine. Here Turing machine can recognize the languages, also can produce the strings to understand, that is enumeration called as. It can produce the strings, so to understand the language it can enumerate the language or it can recognize the language. Everybody? So we have two kinds of Turing machines now. Turing machine can recognize, Turing machine can enumerate. Clear? This is the definition. In previous gate they were asked the language if the language enumerated by Turing machine is lexicographical order, then what is the language? It is a recursive language. Everybody? Now language enumerated by Turing machine is recursively enumerable, but that may be recursive, that may be regular. We are not going to talk about that. So better safe word is recursively enumerable when they talk about Turing machine enumerates. It can be regular, it can be finite, anything, but we don't know. Yeah. Now we are ready to construct the Turing machine, guys. So far I was talking about the theoretical points of Turing machine, which will help you, because in the exam they do not ask about construction. In case if they ask, you just try based on your knowledge. But based on my knowledge, if they ask, we are going to waste our time to understand the Turing machine. Fine. Okay, now how do you construct a Turing machine, guys? You know, yes, some words we can say: language accepted. We have special words: accepted by TM is dash always recursively enumerable. But it may be recursive or may not be, we don't know. Accepted, you can also say recognized. So that is the reason we call it is this language also called as Turing recognizable. You can also call Turing acceptable. It's also called as enumerable by TM, simply enumerable. And language decided by TM is recursive language. Another name of recursive language is decidable language. Another name is Turing decidable. Another name is lexicographically enumerable. Many names for recursive language. It's simply accepted by halting Turing machine is meaning a language accepted by halting Turing machine. Clear? These words can be asked directly in the exam. You can answer as per your practice and understanding. You need to practice a lot to remember these words. That is the reason people fail to answer the questions of Turing machine, because they lack in words, because it's not English language to remember them. It's not easy to remember because of accepted, decided, recognized. These are technical words where you need to use along with the Turing machine. Yes. Now let's try to construct a Turing machine. Now the first problem that I am using, a power n, b power n. Maybe I don't spend much time on construction, so I will directly go to a power n, b power n, c power n, so that you will understand the whole story of this Turing machine. Okay, n greater than or equal 0. Let me take. Some people talk about the Turing machine doesn't accept epsilon. That's wrong, guys. Turing machine can accept epsilon. Only we can't decide whether it accepts or not if somebody designs. Okay, now I'm trying to design this problem. So what strings are there in this language? Epsilon, ABC, A square, B square, C square, that means double A, double B, double C, and triple A, triple B, triple C, and so on. We have so many strings, infinite strings in this language. Now you need to build a Turing machine. Yeah. Now how do you build it? Because we don't have a stack now to push onto the stack, right? But PDA can't do this problem. Now Turing machine can do. How do you do that? Now we have a tape. Let's say I am taking 4 A's, or let's say 5 A's, 5 B's, 5 C's, and apart from your input, all entire tape filled with blank, because you can use infinite tape if you really need it. This is your tape. Now it might take even half an hour to understand the problem, because that is why the Turing machines will take much time to design the problem. Yes. Look at what idea, because Turing machine always begins from here, the first symbol of the input. Now how the Turing machine should work to understand this problem? Any idea, guys? Now sigma is ABC, but tau can change apart from the blank and ABC you might need new symbols to talk about on the tape. See, Vamshi Krish, if you want to join Unacademy, you must have a target. Are you preparing for GATE or are you preparing for competitive program? Right. And if you want to prepare competitive program, you know that you require the self-coding skills. Nobody comes to your mind to code you. But if you want to seriously prepare for GATE, you need our help. But coding, you don't need anybody help in the world. Basically, you need the mind, logics. You need to have a good hard work. You need to have good coding skills, but that will not come by anybody force. You need to have good skills. So that logics you require, but logics you can learn from somebody, but not the coding. The coding is only possible to learn when you sit and when you code and when you understand logic. Remember that. So coding skills cannot be learned by anybody. Remember that. You might inspire by looking at others, but coding skills are possible only when you work hard, when you code on your own. Yes. So I recommend you take the GATE subscription. So enjoy preparing GATE. But yeah. Now we have, if you are interested for programming coding, if you are needed support, then also you can take subscription. But as a GATE faculty, I say always to come to the GATE, right? Okay. Now tell me guys, how do you understand this problem? Any idea? Quick. We need to do a lot today. Any idea how to understand this problem? Now how to check equal A's, B's, C's? Any idea? Idea I want first. Yeah, Raj. Blanks is fine, but blanks will not give you clarity basically. So instead of blanks, because you are moving left or right, it's very confusing, right? Instead of blanks, you can replace replace A with X and go here somehow, go forward and replace B with Y and go forward, replace C with Z. In every scan, you do one thing. In every forward scan, replace A with X, replace B with Y and replace C with Z. Everybody? That's our idea. We are not designed. So that you compared 1A, 1B, 1C. Right. Replaced by something, that's fine. ये first scan है. Second scan, what do you do? First scan, you replace 1A, 1B, 1C. In second scan, you will do this. Right? You will compare these three. In third scan, you will write with some other symbols. And fourth scan, so on, you do it. After some time, all the A's replaced by X, so that all the B's replaced with Y, so that all the C's replaced with Z. And somehow you need to build a logic to understand the problem. Yeah. Everybody? So this is intuition how we approach. But अब तक तो कुछ नहीं हुआ. Just I told you that how to remember it. You remember by writing with some other symbol. Did you remember that? So I have written with new symbols X, Y, Z. Now in this, did I cross my input? Did I use infinite tape? No. This is actually we are building linear bound automata, guys. You are building linear bound automata. Because we never use the infinite tape for this problem. This problem is already context sensitive language, because what we are designing now, we are using just bounded tape. Clear this point? But which really takes much time. Okay, now focus on. Now in this A power n, B power n, C power n, now I want you to understand every scan in detail. . Okay, now look at this is a Q naught. Assume that really I do not know how many states I want to use, but people might predict Q naught job is to replace A with X, and Q1 job is to replace B with Y, and Q2 job is to replace C with Z. And while reverse scan, Q3 job is to find out that somehow where to begin again to do the reverse scan. Yeah, Q naught is going to replace A with X, but immediately it changes the state. It goes to Q1. Now what is the job of Q1? Q1 job is to replace B with Y, but तो जल्दी नहीं मिलेगा वो तो it has to find. Here the Q1 found B, so it replaces with Y, and it has to skip. It has to read all A's. Now when Q1 replaces B with Y, now don't take left turn, take right turn only. But now because now we need to replace C with Z, but the Q2 job is to find out a C, but that's not possible directly. So it's going to do all skips on B, and when the C comes, it is going to replace with Z, and Q2 takes left turn and gives to Q3. What is the Q3 job? Q3 job is to find out where is the next A. This is the next A, but directly it can't find, so it looks at X. It is going to find the X. Where it is that? It is trying to find the X, first X in the reverse direction. When it sees the first X, find first X in reverse direction. Then it gives to Q naught. Now Q naught, it does the same kind of thing that we have done so far. Everybody, this is the first scan only. I need to do so many scans like this, but every scan will have a different combination sometimes. अब तो XYZ नहीं था पहले स्कैन में, सेकंड स्कैन में आएगा. Everybody, देखो रिवर्स स्कैन में Y दिख गया ना, तो you need to skip B and Y and A. Everybody, this is the first scan, forward and reverse. First scan what we have done. Now similarly, you need to understand the second, third, fourth. So let's try. Now I'm going for, instead of second, third, I'm going for some intermediate scan, because intermediate scan will help you to understand the problem rather than, because second, third, fourth, everybody is intermediate scan. Intermediate scan I am doing, remember guys, some intermediate. Yes, that is why Sandeep I am going for intermediate. I can't understand how to deal with Y, X, Y, Z, so you need to go for intermediate scan. So I am assuming there are 3x are already done, so 3b is replaced with y's already done, and 3c is replaced with 3z already done, and I am assuming now at this point Q naught is pointing. After 3 scans, this is the fourth scan I am talking about directly. Exactly, Raj. That is why the people should know why the Turing machine construction will not be asked in the exam. Yes, that is a good point, Raj. You will realize that, because to build a logic it takes time, and if somebody designed, absolutely it takes time to understand the problem. Yeah. Now Q naught, because one problem you require to understand how the Turing machine can be designed. And those people who have the patience, they can learn the programming, they can learn the Turing machine, they can do a lot. And Q naught, A, you know that it replaces with X and goes to Q1. But Q1 job, earlier you are only skipping A, but skip A will not work now to reach the B. Now it has to skip basically two things. Not only A, it has to skip A as well as Y. But when you look at the previous scan, you were saying only skip all A's because Y was not there that time. Because first time you are dealing, right? That is the reason. Everybody? Now you understood Y also going to come into the picture. Everybody clear this point? Y also going to come into the picture. And now Q1, it replaces B with Y and moves to right. Everyone, but goes to Q2 state. Now Q2 previously skipping B only. Now you can see Z also you need to skip to reach the C. So this is actual construction. Skip Z as well as C both. But always move right direction. Now Q2, C replace with Z and take left direction. Give to Q3. And what is the Q3 job? Here Q3 was not able to skip. What was not able to see Z? It was able to see B, Y, A only. But now look at that. Q3 when it is going to skip in this direction to reach the first X. This is the first X now. Here it has to skip so many things. First it encounters Z, then B, then Y, then A. But X it is looking for. It is trying to find first X. Why first X? Because just after X, A might be there. Then it gives to Q0. Then Q0 rotate the same job. Yes. Everybody? Now, the same procedure will apply for all A, B, C. But how do you accept the input? Just in the last scan, you need to be very careful. In last moment, in last scan, you need to be very careful how to accept. You know what happens? All 5x will happen, 5y's will happen, 5z's will happen. You know, I assume that Q3 is coming this direction. Because Q3 when it sees this x and it gives to Q0, everybody knows that. Now Q0 previous all scans it was seeing A, but Q0 first time it's seeing what? Y. This is a trick. When Q0 sees Y, it means there is no A left. It means all A's are compared with B's and C's. It means now no more B and C, you need to guarantee. Now no more B and C. So what it does is Q0 will hand over to Q4, let's say, and Q4 is trying to skip Y's and Z to reach the blank. Skip every Y and Z. Skip every Y and Z because I should not see B and C. If you see, then go to that state. Skip Y and Z. In case Q4 sees the blank, then accept. Go to final. Clear? That means in every problem you need to understand carefully. This is the first approach. And intermediate scan, actually what happens to this problem? And final step, how should I accept this problem? Everybody? And then you can start designing. Now you know that, okay, Q0 to Q4, total 5 states and 6 states to accept. Total 6 states you might require. While designing, you will understand. Can we start now? But you should always take the help of this step, right? Intermediate step. Then you can understand the problem clearly. Are you clear? Have you remembered everything? Can we proceed? I'm helping you. What is a Q0 job? What is a Q0 job? Tell me what Q0 was doing. Replace A with X. Not only that, it is when it sees y, it handovers to Q4, you know that, and Q1 replace B with y. Not only that, it has to skip so many things. What are they, guys? A's and y's, because before b's y's can be there if you have written previous b's with y's. This is another job. And what is the Q2 job? Replace C with Z, but it takes left turn rather than right turn. You need to remember that while designing. But to do this, Q2 has to skip. After replacing B with Y, then so many B's will come and so many Z's may come before C's. And what is the Q3 job? It is going to find the first X, reverse scan. And what it has to skip? All Z's and B's, Y's, A's. But X, no. X is trying to find. Everybody? And these are the main functions of the program. If you think this is a program, there are 4 functions which we are dealing, which are very important in our machine. Okay, now how to start? Let's say Q0. Replace A with X. I'm going to replace A with X. Left or right? Right. Everybody? So here, what is how to understand this problem, guys? Suppose when we are writing Q to Q dash, something like I comma J comma K. What is the meaning basically? I means you are reading, J means you are writing, K means direction. Everybody? So if I am writing A comma X comma R, what is the meaning? Reading A but write with X but move right. Lavjit, why? I'm going to design now. I'm going to design to accept epsilon. TM will accept epsilon, no problem with that. But TM cannot decide. If you ask, are you accepting epsilon? Is there any algorithm to verify? No algorithm. Understand, Lavjit? English language nahi yaar. Kya bolu? TM can accept epsilon, but you can't decide whether the given TM accepts epsilon. That's a different. That is a different. Okay. Okay. It's just like, can a person crack GATE exam? Yes, I can show so many examples in the world. But is a particular person can crack GATE exam? We don't know. It's a very simple problem. Understand? Can a student crack GATE exam? Why not? Can? We can show so many examples in the world. But if you ask particular person, can he crack GATE exam? Don't know. It's exactly same. I can design a Turing machine to accept epsilon. But can we verify Turing machines? Do they accept epsilon? No algorithm in the world. A comma X R. Q1. And what is Q1 job? Replace B with Y. But for that, you need to skip A's. How to skip A's, guys? A right with A, but go right. There is a one transition. And how to skip the Y's? Y replace with Y and take right. Skip A, skip Y. Skip A, skip Y. Everybody? I have written right side Q0, Q1 job. Just follow them. I need to skip A, Y to reach that B. And when you reach the B, what is your job? B replace with Y. Take right only. Take right only because still C is there to compare. And what is the Q2 job? You do it. Replace C with Z. But before that, you need to skip so many things. Skip B's. How do you do that? B right. and z right, so that you can go to C somehow. And now when C comes, you replace with z and take which turn, guys? Take which turn? Left turn, because one scan is over. Then what is the Q3 job? It has to skip so many things in the left direction to reach the first X. So how do you do that? Guys? I need to skip Z, but Z, left. I need to skip B, left. I need to skip Y, left. I need to skip A, left. This many symbols I need to skip in reverse direction, so we keep left. And once the X comes, we hand over to Q0, because reverse scan is over. When it sees the first X, replace with X and take right, because one scan is over. Everybody, look at how we design. Now this kind of machine can scan all A's, B's, C's, can compare all of them, replaces A, X, Y, Z respectively, and final step, Q0 sees what? Instead of seeing A, it sees the Y. That means all the A's are over. Now one job left. Guarantee there are no more B's and C's. Don't go final, guys. Guarantee there are no more B's and C's left. So how do you guarantee? Just stay in same state. All Y's skip, all Z's skip, because no more BC. Then if Q4 can see the blank, what do? I don't care what you do. Replace with anything, go any direction, but go to final. But in this, epsilon is missing. If you want to accept epsilon, what do? From Q0, go to final directly, QF. It can see the blank, then do whatever, go to final. That accepts epsilon. This is to accept epsilon. Now batao, accept kar sakte nahi kar sakte epsilon ko? If you don't give any input, directly head will see the blank. Go to final. Everybody? Now tell me what doubt you have. After spending half an hour, have you understood the problem or not? But those people बीच में आके और लास्ट में आके सर ये क्या है वो क्या, उनको कभी समझ नहीं आता Turing machine. Everybody, if you want to understand the important things, you need to spend the time. Everybody, clear this point? अब बताओ, कोई भी बताया A power n, B power n, C power n, Turing machine होगा नहीं होगा? Yes. Q4 on blank it accepts. No need to write with the blank. You can write with even anything. Dash dash matlab do whatever, I don't care. Go to final, do whatever. Take left, take right, I don't care. Because here, see, already this is not your input. Whatever you are seeing now, this is not your input. You are written with something else. Nobody looks at your tape. Like nobody looks at your stack in the PDA once you are going to final. Is that clear? This tape is blind now. No use of the tape once we are going to the final, because your input is gone. Only we understood your input is valid now. Clear this point, guys? Okay, similarly, I will give you some important points. How do I know that? There is an algorithm, guys. Every finite data I can convert to Turing machine. I am trying to give an algorithm. PDA you can convert, but that takes a lot of time to convert. Like what you have to do, PDA you need to convert into context-free grammar, then context-free grammar you need to assume unrestricted grammar, then unrestricted grammar is you can convert Turing machine. It takes time. But finite data direct algorithm is there, which is very easy. Like suppose I want to understand A star B. This is my language. Can you design a finite automata? Obviously. How do you design? Any number of A's. NFA is also fine for me. No need to go for DFA. Is this finite automata? Of course NFA. Yes, now I want to convert into Turing machine. I want to convert into Turing machine. What I do is, how to convert into Turing machine? Everything draw as it is. Everything draw as it is. Copy paste. We are very good at copy paste. जो फाइनल स्टेट है ना, जो फाइनल स्टेट है ना, वहां से आपको यार एक कैपिटल बी थोड़ा कभी कभी है ना, ये स्टेट का नाम भी ब्लैंक सिंबल से मैच हो रहा है, तो इसलिए वी जस्ट चेंज द स्टेट नेम्स वन मोर टाइम. इंस्टेड ऑफ दैट यू जस्ट राइट Q0 Q1. नाउ क्या करना आपको, पहले स्टेप में क्या करना, जो ए पर ए राइट लिखो, बी राइट लिखो, बी पर बी राइट. That means every symbol just you write with the same symbol and move right. We never come to the left. That means we never try to remember. And जो final state है वहां से आपको blank देना पड़ेगा. Replace with anything and go any direction. I don't care, but go to final. एक नया है बस. Any problem अगर 10 final से 10 final state से उसको non final बना के वहां से blank to the final state दे दो, हो जाएगा. Everybody, this is the algorithm. This is the Turing machine which accepts A star B only. Everyone? That means can I say every regular language have a Turing machine? Don't say finite automata is Turing machine. Finite automata is different. Turing machine is different. But if I have a finite automata, definitely I will also have a Turing machine. Is that clear, everybody? So what you have to do? Yeah, you can do anything, A by X, B by Y, nobody comes back. Still it is right machine, but it is a very simple machine. You can also design if you want. You can also design if you want. As he said, A is there, B is there, and you will never come back now. You will never come back now. So whether you write or not doesn't matter. A blindly X से replace करो, B भी X से replace करो, कुछ भी करो चलेगा. We don't care what you write because we never come back now. We never come back. Okay. Now we are going to understand some important machines like ones complement of a binary number. Very easy, right? Even finite automata also this kind of concept is there, but I don't discuss many problems. It's not much important for exam. Ones complement of binary number. What is the ones complement, guys? ये होता अगर 1 0 1 0 0 दिया, blanks are there remaining. What should be output after some time? This 1 has to replace with 0, 0 has to be 1, 1 has to be 0, 0 has to be 1, 0 has to be 1. Then ये तो बहुत ईजी है ना, बट इसके लिए फाइनल स्टेट जरूरत नहीं है. जस्ट यू नीड टू बिल्ड halt. Just you need to build halt. Halt after performing your job. Halt after completion of your job. या फाइनल स्टेट जरूरत नहीं है. After completion of work. What is our job? Doing ones complement. कोई भी इनपुट बाइनरी इनपुट दे दो दुनिया में, मेरा पास लॉजिक रहेगा, halt हो जाऊंगा पक्का है ना. There no final state is required. So how to build that? Like this is my state. 0 I replace with 1, take right, take right. 1 replace with 0, take right. But जब blank होता ना, blank को blank से ही replace करो, dash मत डालना. क्यों? वो blank 0 1 कभी नहीं होगा, blank blank ही होगा. But move left or right, I don't care. My tape will have the output. So now alt बताओ सीधा, final state जरूरत नहीं. Clear? Blank required to stop, because how do you know your work is over? It's just like a dollar in PDA, just you need to take care of that halting. Yes, generate output and halt. and आपको बताना पड़ेगा मशीन को halt कर दो. चलो अरे ये रेगुलर लैंग्वेज है यार, ये रेगुलर लैंग्वेज है एक्चुअली, वहाँ पे ये पॉसिबल था, मैं ट्यूरिंग मशीन डिज़ाइन कर रहा हूँ उसके लिए, है ना. Yes, you always halt here, but you can design some machines which doesn't halt. This is okay, it always halts here. It was already a problem which we solved in regular languages. Okay, yeah, but don't worry much about it. Okay, now how a Turing machines can build basically, you know, TMs can be designed, accept, doesn't accept a very, you know, a different behavior. TMs can halt or doesn't halt, both are different machines guys. या जो halt होगा तो doesn't halt भी होंगे ना, always halting हो नहीं हो सकता कभी कभी, हाँ हो गए ना लवजीत. ओके, I'll come for that, I'll come for this, है ना. So Turing machine we can build two ways, to accept, to not accept, to halt, to not to halt. Fine. In two's complement, अच्छा मुझे इग्नोर करना था इसको, बट कर लेते. Two's complement of binary. There are two logics. Logic one, do one's complement plus one. ये तो टाइम लेने वाला है थोड़ा, इसको भी कर सकते हैं ट्यूरिंग मशीन में. दूसरा है, okay, let's take an example. Suppose W is 0 0 1 0 1 0 0. This is my input. If you do the ones complement plus 1 1 1 0 1 0 1 1 plus 1, you do it 0 and carry, again 0 carry. Everybody, is that correct? Ones complement plus 1, this is 2's complement of given input. बट इसको दूसरी तरीके से कर सकते हैं, जो W है सीधा ले लेना, you can scan in reverse till the first one, keep same till first one, but after that do the ones complement, do the complement here, do complement. तो क्या होगा, 0 1 बनेगा, 1 0 बनेगा, 0 1 बनेगा, 0 1 बनेगा. देखो ये दोनों सेम है नहीं, 1 1 0 1 1 0 0. right, till first one, skip 0 including that one. तो इसको कैसे बिल्ड करें, how to build the machine guys. Look at, directly I am designing it. Q naught, first आपको ऐड तो यहां पर था, you need to go to the last, यहां पर ब्लैंक है, और उसके बाद रिवर्स स्कैन स्टार्ट करना पड़ेगा आपको. तो क्या करेंगे, पहले रिवर्स स्कैन स्टार्ट करने के लिए क्यू नॉट को बताएंगे आप लास्ट तक जाओ. तो मतलब क्या करोगे, 0 स्किप गो राइट, 1 स्किप गो राइट. जब ब्लैंक आएगा, ब्लैंक से ही रिप्लेस करो, टेक लेफ्ट बट गिव टू Q1. Q1 क्या करेगा, अब Q1 स्टार्ट करेगा काम, Q नॉट नहीं, Q1 क्या करेगा, Q1 is going to skip every 0, 0 0 लेफ्ट होगा. जब 1 आएगा, when 1 comes it gives to Q2, when 1 comes it gives to Q2, but 1 keeps 1, don't replace with 0 now, 1 ही रहेगा, but उसके बाद 1's complement होता. एवरीबॉडी, यहां पर आपको क्या करोगे, आप क्या करोगे, 1's complement बताया ना, 0 1 है ना, 0 1 राइट and 1 0, sorry right नहीं, left. Everybody, so I need a space, so I'm just going other side. 1 1 left, ये Q2 करेगा, क्या करेगा, 0 1 लेफ्ट, 1 0 लेफ्ट. जब ब्लैंक आएगा, ब्लैंक, but don't do anything, don't replace with any other symbol other than the blank. Now halt. Okay, answer. अगर आपके पास टाइम है, यू कैन डू लॉट. डिफिकल्ट तो है, 1 घंटा 2 घंटा लगता है एक प्रॉब्लम के लिए. इफ रियली नीडेड गाइस, यू कैन अंडरस्टैंड द प्रॉब्लम. दिस वन, a पावर n फैक्टोरियल, क्या नहीं हो सकता है यहाँ पर, n पावर n, n स्क्वायर, ये सारे प्रॉब्लम्स के लिए ट्यूरिंग मोशन है. TM एग्जिस्ट फॉर ऑल ऑफ देम नाउ. वो भी halting ट्यूरिंग मोशन होता. इवन लीनियर बाउंड ऑटोमेटा इज देयर, रिमेंबर. And it takes much time to design, remember, not easy. What cannot be done? And now what we are going to do, we have understood how to design TM, but we never practice much because we need to learn the theory rather than. So you need to know about something like closure properties. You must know the fact. Closure properties we are going to apply for 2 languages. For recursive languages separately, and for RE languages separately, recursively enumerable. We need to learn 2 separately. And first remember one thing, 3 properties. I will talk about many other, but before that let me explain these 3 things. Remember at any cost. If you ask me about the recursive and REL, I'll make a big table if you want it, including others, but these 3 are important properties. For recursive, for RE, for recursive languages, for RE languages, union closed for both, intersection closed for both, complement only closed for desirable languages, that is recursive languages, and RE languages it is not closed. So for that, you need to work a lot. Yeah, thank you Nishu. Good morning. Same to you. Everybody, you need to work a lot. You need to learn the proof, you need to learn a lot, but I'm going to give the table to remember many closure properties. Okay, if you want to learn, let me do something for you. Okay. U means union, intersection, complement, and difference, and concatenation, dot, and what else we have, clinic closure, positive closure, reversal, subset operation, and F is the substitution, homomorphism, inverse homomorphism. ऐसे बहुत सारे हैं दुनिया में, but these are the important if you really want to remember. Otherwise I don't care. I never suggest to remember anything, but I want you to understand some of them you might require. Okay, now I want you to understand for these 2 domains. For recursive, for this, for union, intersection, complement, difference, concatenation, clinic closure, positive closure, reversal, subset, substitution. F means substitution, H means homomorphism, H inverse means inverse homomorphism. Everybody? Yeah. Now this is the closure properties table. Here for we are applying recursive languages. Proving really takes time, and union, intersection, complement I have already proved in previous sessions, long term batch. You can go to playlist, I can look at it. And for RE languages, recursively enumerable, F means substitution. वही तो बात कर रहा था मैं. F means substitution. H means homomorphism. And this is the subset. Okay, this is the concatenation. टेबल बड़ी है इसलिए शॉर्ट फॉर्म में लिख दिया, ठीक है. डोंट कंफ्यूज, दिस इज अ यूनियन इंटरसेक्शन. जरूरत नहीं है ना लिखना यार, समझ में आता है यार, कितने बार लिखा हम. कॉम्प्लीमेंट, यस, रेडी. नाउ यूनियन, ये याद रखने के लिए मैं थोड़ा कम कर लेता हूं इसको. इन दिस लिस्ट एक्सेप्ट दिस 3 एवरीथिंग इज क्लोज्ड. तो बहुत इजी होता है याद रखना. देखो शॉर्ट फॉर्म में बहुत इजी होता है. यहाँ पर सबसेट, सब्स्टिट्यूशन, होमोमॉर्फिज्म छोड़ के सब क्लोज्ड होता है यहाँ पर रिकर्सिव लैंग्वेज के लिए. तो ये याद रखना बहुत इजी होंगे आपके लिए. क्लियर? तो आपको याद रखना नॉट क्लोज्ड वन. एवरीवन. और आरजी लैंग्वेजेस के लिए याद रख लो कॉम्प्लीमेंट इज नॉट क्लोज्ड, सो डिफरेंस और सबसेट. रिमेनिंग सारे क्लोज्ड है. एफ, एच, एच इनवर्स सब क्लोज्ड है. यहां पर क्या रिमेंबर करना, सबसेट तो दोनों के लिए नॉट क्लोज्ड है, बट वहां पर सब्स्टिट्यूशन एंड होमोमॉर्फिज्म रिकर्सिव लैंग्वेजेस के लिए and not every operation is important. You need to learn some proofs. अगर आपको if you need any other property Shiva, just you can go and search, but really not important everything. ये already बहुत difficult table है. Just I want you to remember the first 3. This is only important for exam, not any other. Quotient पढ़ना है तो regular language के लिए पढ़ लो, remaining तो जरूरत ही नहीं. Important, yeah. And remaining all are closed. इसलिए यू शुड नो व्हाट टू स्टडी, व्हाट नॉट टू स्टडी. ब्लाइंडली सब कुछ पढ़ लिया, एग्जाम में जाके कुछ याद ही नहीं रहेगा, फायदा नहीं है. एवरीवन, सो रिमेंबरिंग इज सो इजी नाउ फॉर इंपॉर्टेंट ऑपरेशंस. ये भी इंपॉर्टेंट नहीं है, फिर भी एक्सप्लेन किया यार. एग्जाम में इतना बड़ी पूछेगा क्या? कभी नहीं. राइट, आपको पहली 3 कॉलम्स को याद रखना पड़ेगा विच आर वेरी इंपॉर्टेंट. एंड और ये वाली एफ वाली वैसे भी सबसेट इज तो बहुत इंपॉर्टेंट, हम इनवर्स होमोमॉर्फिज्म बहुत इंपॉर्टेंट. सो लास्ट 4 याद रख लेना और फर्स्ट 3 याद रख लेना, बहुत इंपॉर्टेंट है. क्लियर एवरीवन? So at any cost you try to remember this table guys, and which will help you to easily, you can easily answer in the exam, which is really going to help you. So I'm going to help you. So why union is closed? Why union is closed for both the domains? Union is closed for recursive languages also closed for RE languages. I thought I will not explain, but I am trying to do that. RE else. सबके लिए नॉट क्लोज्ड है. कैसे? पहले REL पता है क्या? अनडिसरेबल में बताऊंगा. सबसेट क्यों क्लोज नहीं है मैं बताऊंगा अनडिसरेबल में, अब नहीं. पहले आपको नॉट REL समझना पड़ेगा. उसके लिए सबसेट ऑफ REL मे बी नॉट REL, ये याद रख लेना. पहले सबसेट क्यों है, पहले नॉट REL को पढ़ना पड़ेगा. सबसेट ऑफ REL REL नीड नॉट बी REL. मतलब REL नॉट REL पढ़ने के बाद जो नेक्स्ट कल से आएगा ना, कल पूछिए डाउट, सर सबसेट एक एग्जांपल दे दो, मैं कल दे देता हूँ उसको. नीड नॉट बी REL. पहले नॉट REL को समझने के बाद ये कर देता हूँ. राइट, अब तक तो नॉट REL बहुत कम पढ़े ना. राइट, ओके. Now union is closed for recursive languages. मतलब if you have one L1, that is recursive language 1 union recursive language 2, you are trying to say is always recursive. Always recursive, doesn't matter which recursive you give. What you are trying to say here, RE1 union RE2, you are trying to say always recursive, always RE. Always you are trying to say RE, that is why it is closed. Now how to prove it? How to prove it? See, if it is recursive 1 guys, you have already HTM 1. Let's say this is HTM 2. Please like the session if you are watching and you forgot to like the session guys. Thank you so much. And you know, both of them will always have a logic because of alternating Turing motion. Yes or no? Valid and invalid. Valid and invalid both will have a logic. But valid, it will alter final. Invalid, it will alter non-final. वो दोनों तो halt होगा पक्का. But यही लेकर अब I'm trying to design a new motion. I don't know whether it exists or not. I will try to help you. And if it exists, we will understand definitely. Now I want to test myself, that is, I give an input W and I will check, do you have a logic for valid and invalid? So how do you say valid, invalid for this case? If you give a W, I need to prove that W belongs to, that is union, means valid. Recursive 1 union recursive 2. And W not belongs to recursive 1 union recursive 2. How do you prove that? Logic for them. You should prove that you should halt here. You should prove that you should halt here. How to prove that? To prove that, if both machines, I'll give this W to both machines. It's like both algorithms. If anybody halts at final, that means somebody accepted. So look, these two algorithms. ऐसे लॉजिक अप्लाई कर दो, ये डिजिटल लॉजिक नहीं है, जस्ट ये प्रोग्राम है. इफ एनीबडी हॉल्ट्स, सॉरी व्हाट आई एम डूइंग, इफ एनीबडी हॉल्ट्स you also halt at final. If anybody halts, you also halt at final. If any HTM halts at final, the new motion halts at final. Yes. ये invalid क्या है? Invalid जब होगा if both motions halts at non-final, मतलब that string is not accepted. Yes or no? Yeah. So उसके लिए आपको and logic अप्लाई करना पड़ेगा. If both, मतलब यहाँ पर अप्लाई करेंगे, if both HTM halts at non-final, then new motion halts at non-final. Everybody? Similarly, you can apply for valid logic in Turing motion. No need to apply invalid logic. Right? Now I will explain for the union for RELs. Now RE1 union RE2, I have to prove that always RE. How to prove that? Same. If this is a TM1, then you will alt for belongs to only. Right. L of TM1, that is RE1. And here not belongs to, don't worry, because we never build, we don't try to build. Don't worry here, because we don't care. Here we always halt, there we don't know. Okay, same. This is a TM2, and if W belongs to language accepted by TM2, definitely we will halt. But इसके लिए पता नहीं है. W अगर नहीं है, not accepted है, तो बता नहीं सकते. कभी कभी infinite loop में भी जा सकता. Don't worry, logic में may not be there. तो इसको दोनों लेकर can you build a new motion for union? These two are given to you. Now new motion I am building. You have to prove only logic for this. Here don't worry. Here don't worry. We don't care logic here. And give this both. Give this W to both. In case TM exists for the union, then W belongs to a union, that RE1 union RE2. We need to prove the halt. How do you prove it? Take this logic, and if any one of them all set final, you also all set final. You also alt, right? If it is invalid string, even we don't know how to prove it. That is, we got a new TM. This is a TM definition again. Belongs to have shown a logic, not belongs to no need to show the logic. No need to show the logic here. No need to prove here because it's a Turing machine. No need to show. If you have a logic, it's okay. Yes, everybody? It's a union. Similarly, intersection you can build, only complement you can't, because the invalid strings you can't show the logic all the time. Yes. Similarly, try to understand, guys, intersection, complement, not required for the exam point of view, but interviews they may ask. Can you prove why union is closed for recursive and REL? Right? So it's very important for you. So I want you to understand what for the next chapter, what we need is complement, guys. And most of you are required to understand this logic, what I'm trying to speak now. Yes, Lavjit, just you need to remember the table. That's why people always remember the table rather than wasting their time. Devraj, TM rejects, but we will never know how to prove it. It rejects. Does not accept W means it is rejecting, but you will never know how it rejects. Because it will not tell you sometimes I am rejecting the string. Okay. Come to the discussion, not here. Here we have very limited time to cover the concepts, right? Yeah. Okay, I'm just focusing on, assume these are all languages, this box name, set of all languages, means every language is inside here. This is set of all RELs, don't say one REL, box name it is. It's a box name. And this name is, okay, that I can write inside also because no more boxes inside here for me. So I can write inside set of all recursive, set of all recursive languages. Okay. Now what you require to understand is the complement property. Complement property, right? And you know, so many languages are there, you know, A, B, C, D, E, F, G. ये सारे languages मान लो, languages, assume them. Infinite such languages are there. Infinite such languages. Everybody. So if I ask, what is A? What is A? A is dash. It is the language, but it is recursive. Not only just recursive, it is RE also. It is RE also. Clear? This is about A. Similarly B. Now I'll just take one in the box. C is there. What is C is very special. What is C, guys? What is C? Because it's a very special. They are all, it's set of all REs, but they are not recursive. Okay, C is RE but not recursive is a good name, but it is also simply RE. Fine. Here A and C both are RE, remember that. And when we talk about G, what is G is? G is not RE, because outside this languages we call set of all not RELs. Clear? पुष्पेंद्र कहाँ से आया यार, किस दुनिया से, ये प्लैनेट से नहीं है बंदा। चलो ओके, डी इज आरएल ना, अरे यार से आरएल के अंदर है ना, क्या यार शांतानु, डी आरएल के अंदर है यार, ये डी आरएल के अंदर है, सेट ऑफ आरएल, येलो बॉक्स नहीं दिख रहा, येलो बॉक्स के अंदर सब हर लैंग्वेज इज आरएल यार, रिकर्सिव नहीं हो सकता, रिकर्सिव नहीं है वो शांतानु, कमान यार, लिख दिया, अब लिखने के बाद ही डाउट आ रहा है यार, समझ नहीं आता क्या, ये नहीं दिख रहा है क्या वर्ड, इसके अंदर येलो बॉक्स के अंदर सब कुछ आरई है यार, डी कैन बी नॉट आरएल, क्या है वर्ड, क्या है शांतनु, मैं आरएल के अंदर, इंडिया के अंदर बैठा दिया, बोल रहा है इंडिया से बाहर हो सकता, नहीं यार ऐसा नहीं बोलना, समझ लो बात को, ठीक है। अब मुझे क्या चाहिए गाइस, अगर ए को कॉम्प्लीमेंट किया कहा जाएगा, वो ए का कॉम्प्लीमेंट अंदर ही रहेगा, मतलब ए रिकर्सिव कॉम्प्लीमेंट इज रिकर्सिव, मैं ये बात करना चाहते हैं, बी कॉम्प्लीमेंट कहाँ रहेगा, अंदर ही रहेगा, मतलब वो भी रिकर्सिव है गाइस, वो भी रिकर्सिव है, बट सी का कॉम्प्लीमेंट अंदर नहीं रहेगा, सीधा बाहर, क्यों, वो सी ऐसे वाली प्रॉब्लम है, उसका इनवैलिड स्ट्रिंग के लिए लॉजिक नहीं है, तो इनवैलिड वैलिड बन गया ना, उसका लॉजिक कभी नहीं बनेगा, डी का कॉम्प्लीमेंट क्या होता, सीधा बाहर, एफ का कॉम्प्लीमेंट क्या होता, सीधा बाहर, मैं एफ दिया, एफ कॉम्प्लीमेंट नहीं दिया, याद रख लेना, आई हैव ओनली गिवन रिमेंबर, ए बी सी डी ई complements are not given, I am finding it to explain you how do they work. Okay, अब कितने लोग को पता जी कॉम्प्लीमेंट क्या होगा, वेयर इज द जी कॉम्प्लीमेंट, अगर नॉट आरएल है तो ये कल यही से स्टार्ट करूंगा, इसलिए मैं बता रहा हूं आज यही से स्टार्ट होगा कल की क्लास, अनडिसेबल समझना है, इसी बॉक्सेस से करना पड़ेगा आपको। नाउ जी कॉम्प्लीमेंट क्या होगा, जी कॉम्प्लीमेंट कैन बी एनीबडी, either here or here, it is anywhere, it depends on the problem. Yes, C D F complement always not REL, exactly right, and H का complement भी सेम है, वो यहां रहेगा, नहीं होगा तो इसमें अंदर जाएगा, बट डिसाइबल में कभी नहीं जाएगा, और ई का कॉम्प्लीमेंट भी यहां रहेगा, नहीं होगा तो इसमें आएगा, यस इसके लिए डेफिनेशन जरूरत पड़ेगा समझने के लिए, बट इसको पहले पकड़ लेना, तभी हम कल यही से स्टार्ट करेंगे ना, अनडिसेबल में यही क्लासेस पढ़ेंगे ना देवराज, अनडिसेबल में तो यही तो पढ़ेंगे, ये स्टार्ट हुआ अनडिसेबिलिटी, जिसको ये नहीं आता अनडिसेबिलिटी कुछ नहीं होगा, अनडिसेबिलिटी स्टार्ट हो गया एवरीबॉडी। तो अब इसको समझने के लिए एक एक बात, व्हाट इज प्रतीक, डिड आई यूज एनी अनडिसेबल वर्ड, यहां पर क्यों यूज कर रहा है प्रतीक, अनडिसेबल वर्ड यूज नहीं किया, आई विल डू टुमारो, आई विल एक्सप्लेन, क्लियर। चलो एक थोड़ा हिंट दे देता हूं, कॉम्प्लीमेंट ऑफ रिकर्सिव लैंग्वेज, एक एक समझ लो, इज डैश क्या होता, बताओ, आप बताओ, कॉम्प्लीमेंट ऑफ RE बट नॉट रिकर्सिव। इसका कल प्रूव करूंगा सारे। एक लैंग्वेज का नाम है कॉम्प्लीमेंट ऑफ RE, L ले लो डैश, एंड कॉम्प्लीमेंट ऑफ क्या है और नॉट REL। पहले आपको ये पता है क्या रिकर्सिव लैंग्वेज क्या है, RE बट नॉट रिकर्सिव, REL नॉट REL, तभी ये आंसर बनेगा। कॉम्प्लीमेंट ऑफ रिकर्सिव इज हमेशा रिकर्सिव। RE बट नॉट रिकर्सिव मतलब RE के अंदर है बट लेकिन रिकर्सिव से बाहर है, मतलब वैलिड स्ट्रिंग के लिए लॉजिक है, इनवैलिड के लिए लॉजिक नहीं है। ट्यूरिंग मशीन है बट लेकिन HTM नहीं है। इसका मीनिंग क्या है, TM एग्जिस्ट बट HTM नहीं होता, उसको कभी नहीं होता, ओनली TM एग्जिस्ट। ये बोलते नॉट RE सीधा। एंड कॉम्प्लीमेंट ऑफ REL, कॉम्प्लीमेंट ऑफ REL कितने लोग को पता, व्हाट इज द कॉम्प्लीमेंट ऑफ REL? ये बहुत खतरनाक है। लोग बोलते बहुत सारे आंसर्स है, एक नहीं बहुत सारे आंसर्स है, क्या क्या होता। लोग बोलते हैं नीड नॉट बी REL, बट कुछ समझ नहीं आया मुझे, नीड नॉट बी मतलब क्या है एग्जैक्टली। ये है आइदर रिकर्सिव ही हो सकता और नॉट REL होगा, बट कभी भी RE बट नॉट रिकर्सिव में नहीं होगा, है ना। इसका सारे मीनिंग कल बताता हूं मैं। ये होता नेवर, ये REL के अंदर जो भी ले लो गाइस, ये REL के अंदर जो भी ले लो, कोई आया REL बट नॉट रिकर्सिव के अंदर, RE बट नॉट रिकर्सिव के अंदर कोई आया, सिर्फ REL के अंदर ले लो। रिकर्सिव लिया, रिकर्सिव में अंदर है, रिकर्सिव से बाहर लिया, वो सीधा बाहर चला गया नॉट REL में। तो नेवर बी RE बट नॉट रिकर्सिव। अगर नॉट REL को कॉम्प्लीमेंट किया, हो सकता वो आइदर नॉट REL भी और RE बट नॉट रिकर्सिव, बट रिकर्सिव कभी नहीं होगा। क्यों? रिकर्सिव होगा तो उसका कॉम्प्लीमेंट वहीं पे रहेगा, यहां नहीं आएगा। एंड दिस इज अ बिगिनिंग ऑफ द वर्ड्स ऑफ अनडिसाइडेबिलिटी। इसको एक एक प्रूव करूंगा नेक्स्ट क्लास में, पर टाइम लेगा नो डाउट। दिस आर द डायरेक्ट गेट क्वेश्चंस, बट इतना आएगा, बट समझने के लिए बहुत टाइम लगता है, एग्जाम्पल जरूरत है, और एग्जाम्पल तो अब तक स्टार्ट ही नहीं हुआ। एवरीबॉडी yes, if recursive then recursive, if not recursive out of RE, exactly, good Pratik, समझना बहुत जरूरत है। So it's okay, fine guys, so remember these points, these are very very important points for the exam, and I'm going to bring tomorrow the extension of these sentences. Now to understand these 4 lines, how we expand this topic to undecidability. Okay, so in the next class I will be helping you the undecidability. Today I help you what is Turing machine and definitions of recursive and definition of RE and just construction for few problems to understand. So if you ask me, sir, what is important for gate? So remember closure properties and know how to construct the Turing machine, but no need to practice much, and directly go to undecidability and practice lot. Everyone, so tomorrow in the next class we are going to look at next same timing tomorrow 9 to 11 AM, that is undecidability begins. Yeah, tomorrow we'll discuss lot of problems. Yeah, and after this class you may attend which class today? Operating system first class, guys. Please attend this session, very important. And then you will have data structure is going on, I think from 2:30, from 11:30 operating system. And in case if you are interested to take the Plus or Iconic, we are always there to help you. Plus is a systematic structured courses, and we'll have live interactive classes and many batches. You can attend any batch or every batch. You can go to any educator, you can attend any live, and you can use my referral code or anybody referral code. But you are following my classes, I recommend to use my code just to get advantage of me. And yeah, if you want my support to prepare the GATE exam, then definitely use my referral code, and you can learn the subjects in both English and Hindi mode, and doubt solving and weekly tests. So many benefits. Iconic, all the benefits of Plus. Additionally, dedicated coach and monitor. The people will help you to prepare for exam, and you will have a separate study material and many more benefits. In case you need the prices, for 2 years of Plus plan, you have 39,600 after using my referral code, and Iconic, and for 2 years 66,600. Here you can use any referral code or my referral code. It is your choice. Yeah. Thank you so much for attending. This is my profile link. If you are attending this class first time, visit this URL unacademy.com/devagate CSE. You will find a lot of free classes, and to unlock them, use my referral code devagate live. And this is our Telegram channel. Please subscribe to this channel, and you will get daily links and material and notifications from us. And you can share our YouTube channels with your friends. Mechanical, civil, electrical, electronics, so many channels are there which are absolutely free. A new channel is there, Unacademy by RBR2, Unacademy CS, yes. And thank you so much. Take care, bye bye. See you in the next class, bye bye. Thank you, take care, bye bye.